Today's lesson will be on lesson 8-1, the imaginary unit, on page 121. We're going to look at two things: the definition of a complex number, which we use I to denote that, and we're going to look at complex numbers written as A plus BI and identify what's real and what's imaginary. So we're not going to be graphing, so I marked that objective off. So to start us off, let's look at this quadratic. X squared plus 1 equals 0. Well, let's try to factor it. What two numbers can we multiply to get 1 and add to get 0? Well, is it possible? No, it's not. There's no solution. You could have even tried to solve for x, like we did in some of the bell ringer problems. And notice when we would take the square root, we get x equals the square root of -1. So what I want you to do is type square root of -1 in on your calculator and let me know what you get. You should have gotten no real solution. So in all these problems that we've done before, and even problems you've approached in Algebra 1 and geometry, anytime you get no solution, it really means no real solution. Today we're going to look at how you can get an imaginary solution. So let's look at this problem. We want to figure out what two numbers sum to 10 and are the product of 21. Remember, sum means add, product means multiply. So take a second on your own to think about that. So you should have gotten 7 and 3. Because 7 times 3 is 21, 7 plus 3 is 10. So this relationship, we can write a function to represent it. So let's say instead of 7 and 3, we could do any x value. That could be represented, like this could be our 7. And therefore, if you did 10 minus 7, you would get 3. So let's check this function. So if x equals 7, we would have 7, then 10 minus 7, which is 3. 7 times 3 is 21. We checked it. Okay, what if x had been 3? So again, we do 3 and plug in 10 minus 3. This should equal 21. Let's see, we get 3 times 7 equals 21. So it does check out. So this function represents that relationship that we looked at in number 2. So we're going to use this function as a quadratic and solve for it in just a second. Okay, so let's turn to the next page, page 122. So from the previous page, our function was x times x times 10 minus x equals 21. We can distribute that x. It's kind of similar to that perimeter problem we did on our test. And we get 10x minus x squared equals 21, just by distributing that x. So notice, this quadratic is not in standard form. How do we know if a quadratic is in standard form? And then also, how can we solve a quadratic? Because right now this is equal to 21. What should our quadratics be equal to solve? So remember, quadratics should be equal to 0. So this is obviously not equal to 0, but we can get it that way by subtracting 21 to the other side. Now, is this in standard form? No, it is not. So let's rewrite it so it is in standard form. We're just rearranging the terms where the x squared goes first, then the x, then the constant. All of that is equal to 0. Now, you may be kind of concerned about this negative in front. All we need to do is just factor out that negative. Basically change all of these signs. So now, right here, what's inside the parentheses, we have a quadratic that we could factor if needed. So let's try to factor this. let's figure out what multiplies to get 21, adds to get negative 10. We should have gotten negative 3 and negative 7. So that means our factors are x minus 3 and x minus 7. So if those are our factors, then our x values are x equals 3 and x equals 7, which you may remember from the previous page where we started with that guess and check type problem. Okay, so notice our answer are whole numbers, just 7 and 3. They are what are called real solutions. These are real. They are also called roots or solutions, or remember we also call them x-intercepts. So if we were to graph, we would see our parabolic cross at 3 and at 7. Well, what if we'd gotten some sort of x values that looked like this? Where we have a real number, and then we have the square root of a negative. A real number and square root of a negative. These are what are called complex numbers. These complex numbers have a real number and then an imaginary number. So how do you know if you have an imaginary number? You know you have an imaginary number when you have a negative underneath the square root. So let's scroll down. So right here, we have a very important math term. Imaginary numbers are when you have the square root of a negative. So anytime you have a square root and a negative underneath, you have an imaginary. So like I is just square root of negative 1. So let's look back at the problem from the that we started with at the original on page 1. X squared plus 1 equals 0. Well, earlier we solved it, or we tried to factor, and we got x equals the square root of negative 1. And that's where we stopped. But now we can go a little bit further, and we can say that square root of negative 1 is an imaginary. So we just put an I. This would equal I. Okay, so let's look at square roots with an imaginary term. So right here, the square root of negative 3. Well, because there's a negative, we know there's going to be an imaginary. So another way you could think about this is square root of negative 1 times 3. Notice, negative 1 times 3 would still give us that negative 3. Well, both of these terms are underneath the square root, so we can write them as square root of negative 1 times square root of 3. Well, now we know the square root of negative 1 represents a value, and that is I. So we write I, and then square root 3. That would be our final answer. Okay, what about square root of negative 16? We know there's going to be an imaginary. So this is square root of negative 1 times positive 16. Because again, if we multiply those together, we get negative 16. So this is square root of negative 1, square root of 16. Well, square root of negative 1 we know is I. Square root of 16, if you type that in your calculator, what do you get? So you should get 4. So the correct way to notate this would be the real number first, then the imaginary. So 4I. If you got I times 4, that is still correct, but let's order it in the correct notation. Okay, let's look at one more. It's a little bit harder. So right here, this is square root of negative 1 times 8. So I want you to try this one on your own.